that's what we're going to do. We're going to do questions. I'm going to start off with just a basic, find a missing angle, find a missing side, and then we'll move on to the fun ones, which are the puzzle ones, and hopefully get a lot of those done. So
I actually had a quick question.
Oh, that's good. Go for it.
So on that last one we did, right?
I can't remember the last one. Have you got it handy?
I do.
Right.
One of the
What was
sides was a 5, 18, 17.
Right, so we have a 5. Doesn't really matter where I put them now. 18, 17. Right, that guy.
Yep, and then
Great.
the top angle was we found was 70.5.
Okay, provided I did the right calculations.
Yeah.
Okay.
I just, to make sure I grasped the full concept, I found the other two angles, right?
Yeah.
And one of them ended up as 86.46 and the other one was 16.10, and it doesn't add up to 180. It was like 173.
Oh, that's a bit have you double checked the 70.5 wasn't 72.5, and maybe that's where the mistake was?
Yeah.
Just make it was 70.5?
Yeah.
Okay, then let's do this question and see if we can figure it out. So we'll assume that the first one was done correctly, right? So we got this angle, it's 70.5, and there wasn't any rounding off issues that were going to cause big deals. I guess it doesn't matter who I call A, B, and C, so I'll just call it that way. Now, if I want to find angle B, right, let's make that the next one. That one there is probably going to be the tiny angle. And the reason I know that is that there's a property that you can use when you know all three sides. The biggest angle is going to be opposite the biggest side. So I bet you angle C is going to be the biggest of the three. The smallest angle is always opposite the smallest side. So I bet you angle B is going to be the smallest, and that one's going to be the middle. And that kind of fits the numbers we've got here. So cosine of B is A squared plus C squared, take away B squared over 2AC. Are you all comfortable about that formula? Because I know there's 3 of them. You remember the guys, we wrote them all down. That look good? Okay, so I'm going to plug in.
That's what we did to find angle A, and then I just
no. This is what we're doing to find angle B.
Okay.
Right. So I better put the names in here. Our lettering might have been different from the first time, but that really is only cosmetic. Right. So in this case, A is 17, C is 18, and B is 5. And it's going to be 2 times 17 times 18. And that's what the cosine of B is. And if you're brave, can't you just take the inverse cosine of both sides? So what I'm going to do here is a little bit risky, but it does save a whole load of work if I do it this way. Would you agree that that horrible calculation is going to be angle B? Okay, so here we go. Brackets are important. So if you don't put brackets in, weird things happen. So I'm going to do another bracket. 17 squared, add 18 squared, take away 5 squared. Close the brackets. Divided by, start a new bracket, 2 times 17 times 18, and close that bracket, and then close the last bracket. And I am looking at 16.098, and that's exactly what you said, because you told me it was 16.10. Agreed? So check.
Yeah.
And we already are assuming that that's correct. And so what I would do normally is, wouldn't I just add up the 2 that I know, and what's left would be the third one? Wouldn't that be a quicker way of doing it? Since I know this angle and I now know this one, couldn't I just say, if you add these 2 together, you get 86.1, then won't the third angle just be 180, take away the 2 that you know, and that would leave me with 93.9 degrees if I count right, and I'm probably damning.
0.4 is what I got.
What do you mean 0.4? I can't add?
90.4.
Oh, so you get 93.4, and I got 93.9, right? I would suspect that that is simply just rounding off issues. And there's no way, okay, there is a way. Couldn't you do every calculation to pick 12 decimal places to make sure there's no rounding off errors? But you probably aren't. And so I'm happy with that because those two match. Now, I'm assuming you did the 93.4. Did you do it as a calculation?
I went in and did the law of cosine, or sorry, the law of sine to find
okay.
angle C.
Okay, let's just do it then.
Yeah.
And I want to see a 93 point something, agreed? That's what we want to see. And we don't want to see an 86, right? Which is what you said you got. So cosine C is going to be a squared plus b squared, take away c squared, all over 2ab. And so the cosine of angle C is going to be what's A in my story, 17, B, 5, take away C, which is 18 squared, all divided by, okay. I think I know the mistake. I can tell you what's going to happen. Yeah, you're going to get an answer that is going to be that guy, even if it doesn't look like it. So it's going to be this fella.
Yeah, and so to solve that, what I did is I took 180 minus 86.
Yeah,
and I got 93.
That's exactly what you did wrong now. In the cosine questions, you don't need to. Whatever answer the calculator gives you is the right one. So when you come to do C, you are just going to do the inverse cosine of this ugly guy. And I bet you that guy's one of the 93s. So let's just prove it. Inverse cosine, I need a bracket, 17 squared, add 5 squared, take away 18 squared. Close the brackets, divided by, start a new one, 2 times 17 times 5. Close a couple of brackets. Do you see that 93.4 that someone earlier went and said they got?
Yeah, that's what I got the second time.
Yeah.
So I did the law of sines to get the 86 point.
Now when you do the law of sines, isn't there two possible answers?
Yeah.
And you picked the 80 thumb one when actually the answer was the other one.
Okay.
So I would avoid using the laws of sines, because if it gives you two choices but only one of them's right, isn't it sometimes hard to tell which one was the right one?
Mm-hmm.
Whereas if you use the cosine rule, you don't have two choices, right? There's only one answer, and that's the one you use, which is why I would stick to the cosine rule in that particular question. I would also, if I know two of them, can't I just use math to figure out the third one?
Yeah.
Right, and that saves you a big chunk of work. But that was a good question for us to do. So if I give you 3 sides, can't you find all the missing angles? And can't you do it by just using the cosine rule? Right, get that one. Cosine rule, get that one. And then what's left to get the third one? So just using the cosine rule twice would work. So the second question, or the second situation I want to do, would be a question where you know 2 sides and the angle in between. That's not the one. See if I can find a homework question that does that. Yeah, this one. And so this is a version of question 6. The numbers keep changing, so even if I've done this one, it'll still be fine. Got a C up here, got an A here, we've got a B here. This side is 10, this side is 16, and this angle in here is 120 degrees. And in these questions, when you're given this information, you can only use it right now to find a missing side. So this is 120 degrees, so this is called little c. And this angle is B, because over here is little b, and this angle here is A, and it goes there. I'd be comfortable about the naming. Now, which side are we going to get? Obviously the C, right? So if you know 2 sides and the angle in between, the cosine rule will allow you to get the third missing side. In this case, it's going to be C squared. I'll take volunteers. What is the formula C squared equal going to look like?
A squared plus B squared minus 2AB cosine C.
Now, if you've got them written down, that's fine. I think it's better if you can just memorize them. Isn't it a lot quicker if you just know the answer than trying to hunt for the piece of paper that you wrote it down in my opinion. So in this case here, it's going to be 16 squared added to 10 squared, take away 2 times 16 times 10, and finishing with a cosine of 120 degrees. Although I could do that in one go, I'm actually going to do it in two. So I'm going to find out 16 squared, add 10 squared, take away 2 times 16 times 10 times the cosine of 120. And the answer I get is 516. And then I go and I write down 516 and it tells me I'm wrong, because don't I now have to find the square root? And since this is a line, isn't it only the positive square root, right? It's a distance. So I could then do the square root of 516 and get some ugly decimal, 22.716, if you want the answer to 3 decimal places, which they do. Now, once I know this side here, I can then move to find all the other missing pieces. In this case, aren't the missing pieces angles? Right, I can find angle B, and then I can find angle A. And here you've got a choice. Couldn't I use the sine rule to find angle B, right? There's enough numbers there, and I could use the sine rule to get angle B and angle C. Isn't there enough information there to get angle B using the cosine rule? So it's up to you. Me personally, I'd use the cosine rule. And you might say, well, why use that one and not the sine rule? Remember, the sine rule has 2 possible answers. And didn't somebody today have the problem of they picked the wrong one of the 2? If you do the cosine rule, won't you just get the answer? So me personally, in these kind of questions, I just use the cosine rule everywhere. So I would say, okay, I'm going to get you next. And that would start off as the cosine of B is A squared plus C squared, right? What else?
Minus C squared divided by 2AB.
Well, 2A. Why am I calling that C? There we go. My apologies for getting my letters all mixed up, because you were right and I just wrote it down wrong. So A squared plus C squared minus B squared over 2AC. And you get that answer. I believe in this question it's 22.4. Okay. If you know that angle and you know that angle, can't you just take the shortcut for the last one and just add them up and take away from 180? And if you did, I believe the answer ends up being 37.6. Now, if you insist on doing the sine rule, you can decide which is the correct answer by using this trick. Biggest angle, biggest side. Smallest angle, smallest side. Middle angle, middle side. So if you pick an angle and it doesn't fit that pattern, shouldn't it be the other one that you should have chosen? Because you're going to get 42 degrees or you're going to get 138 degrees, right? And would you agree, because of that 120, wouldn't the answer be the small one, right? If that was 12 degrees, couldn't this answer, actually be something other than the one I just mentioned? Do you want me to do any more of these find the missing sides from triangles or find the missing angles? Or do you want me to move on to the puzzle questions?
I think one more would be good.
One more. Okay. Has anybody got a question that they're doing in homework that might be a good one to do? That would be a helpful one, because maybe there's something awkward about it that I could help. Anybody got a particular one? Otherwise, I'll just pick something. Nobody got a preference? Right, I'll just randomly pick one. So the one I'm picking is 11. In question 11, you've got a triangle that looks something like this. This is called A, and this angle's called B. This one's called C. In this question, angle A happens to be 20 degrees. Angle B, okay, it doesn't look like it's around 10 degrees, but this is just a thing you put the thing in. And and this side up here is 50, right? So little b, little c, little a. And we're being asked to find this guy over here. So they called it x. So I'm only after one guy, this guy. So when I look at this, I'm trying to find a squared. So that's going to be b squared plus c squared, take away 2bc cosine of a. And that's going to be, what am I doing? I'm not doing that. This question doesn't work with the cosine rule, does it?
Yeah, I was going to say you have to use the sine rule.
I'll have to use the sine rule. So before I use the sine rule, shouldn't I find out how big c is? Because that's going to help. Right. So this is 20, this is 110. What's left for angle C?
It'd be 50.
50. Now, the reason I knew that that didn't work, I should have looked. Don't these cosine rules only work if you know two sides and the angle in between, or if you know three sides? Can you remember the original picture didn't have either of those two situations? So if it ain't those two, it's going to be the sine rule. That's how I remember. If it's three sides or two sides in the angle in between, it's a cosine rule. Everybody else, it's a sine rule. That's how I remember. So got my horrible triangle. I know it's a mess, but that'll do. I'll do the sine rule, which is fine. I happen to know all the angles, which is good. And I know, well, I'm trying to find little a, and don't I know little b? So in this context, won't it be these two that we'll use? You comfortable with the sine rule? The angles that you know are trying to find, pick the pairs that work. So in this case, it's going to be the sine of 20 degrees over x is going to be the sine of 110 degrees over 50. So x times the sine of 110 degrees is going to be 50 times the sine 20 degrees. To get x, then you just divide both sides by the sine of 110. Should be able to do that in the calculator. 50 times the sine of 20 divided by the sine of 110. And it looks like I'm looking at 18.20 if you round it off to two decimal places. And yeah, that is actually the right answer. So looks like they're mixing and matching now. Aren't they throwing questions in just to throw you where you have to use a sine rule? Before I go on and do the puzzles, I'm going to randomly put in some triangles. just randomly putting together some triangles. And the question isn't the answer. The question is sine rule or cosine rule. So imagine the question was solve the triangle. In other words, find everything that's missing. Sine rule or cosine rule. Let's start with this guy.
Cosine?
So you have got two sides and the angle in between. Agreed? Isn't that one just an extra piece of information? So cosine rule would work. Keep going.
It could be
Someone
either,
else?
actually.
Yeah.
You could do sine for that.
So do you see that you could have a question where both work? So I didn't realize that when I made it, but it is correct. I think this one's much more obvious. There is only one correct method for this triangle.
That's cosine.
Yeah. There's nothing that's going to help you. Now, once you got one of the angles, can't you then switch over to the sine rule if you want? Me personally, I stick to the cosine rule all the time in that situation. I think this one is also clear. Which rule? Two sides and the angle in between. No, two sides and the angle.
That one? That's
between.
cosine.
That's the cosine, this one here. Now, if you're looking at this one over here, right, this one here.
Yeah, that one's sine.
That's a sine rule. So if you know all three sides, or you know two sides and the angle in between, which is these two situations there, cosine. If any other permutation works or happens, you can certainly use the sine rule. Be comfortable with that little rule, because you're going to get puzzles in a few moments where they won't tell you it's a sine rule or a cosine rule. In fact, I bet you they'll stick in a SOHCAHTOA as well, just to keep you on your toes, right? And you're going to have to mix and match those methods to find a missing angle or a side or whatever it is you're looking for. So let's see if I can find one of these guys. Here's one. This is question 17. And we have a picture of, it's like a pond. And there's a straight line going from here to here. And this is called C, and this is called A. And there's another one way up here, another point called B. And then there's a little dotted line going from here to here. And the angle that's at C is 40.3 degrees. And the distance from here to here, which is basically little a, is 2.52 miles. And this is little b, the distance from here to here is 3.9 miles, 91 miles. And we are trying to find out how far away these two people are. So if you imagine someone's got really good eyesight and a pair of binoculars, a radar station or whatever, you can figure out that distance. You then bevel it and have an angle and you figure out that distance. And we are being asked to find this fella. We are being asked to find little c.
So I just had a really quick question, kind of not related to this question. But
okay,
if you're only given three angles, you cannot find the sides, correct?
Correct.
Okay.
Yeah, if I just tell you it's 40, 20, and 120, the reason you cannot find anything if you know only three angles is, couldn't it be a little baby one or a huge big one and have the same angles? Right. So if anybody ever does that to you, after you finish swearing and spending half an hour trying to get the answer, well, you just remember to yourself that some triangles are impossible to solve, right? In fact, aren't some triangles impossible to solve if you put in weird numbers? Here's an impossible to solve triangle. Would you agree there's no triangle in the world? Oh, that's a bad choice. Yeah, that's a good choice. I was starting to imagine it here. Would you agree there's no triangle in the world that could be 100 apart, but the two sides are 5? Imagine those two sides. Isn't the best they could do is fold in on each other? And even if they do that, isn't that only 10? That triangle is impossible. If I tell you the 3 angles, it's impossible because isn't there an infinite number of answers? Now I've drawn that poor picture with stuff on it. Which rule, sine rule, cosine rule, whatever, would you use to solve that question?
Cosine?
Agreed. What made you decide on the cosine?
Well, you have 2 sides and an angle in between.
That's it. That's how you tell. So in this question, it's going to be c squared. Okay. Usual question. Finish the formula off for me. C squared equals
a squared plus b squared minus 2ab. Well, yeah, times cosine c.
Yeah. So we are going to be doing 2.52 squared plus 3.91 squared. Take away 2 times those 2 numbers and finish with the cosine of 40.3 degrees. And as ugly as that is, isn't it really just a calculator job? So the numbers can be as ugly as they want. So 2.53 squared, add 3.91 squared, take away 2 times those numbers multiplied together, finish with a times cosine, in this case of 40.3. Fingers crossed. $2.52, yep. 3.91, yep. That looks good. Take away 2 times 2.5. I just seen a mistake. Okay, that looks better. What do I do now? How do I find C?
Just take the square root of that, correct?
Yeah. So square root of the answer, and I got 1.22 to 2 decimal places. Kind of looked a bit small, but I guess couldn't those 2 things be quite close to each other? You know, I guess 2.2 could work. If I got this distance a lot bigger than these 2 numbers added up, wouldn't that be a good indication I screwed up somewhere?
Isn't it 3.91?
What did I type in?
I think you typed in 3.19.
I did. I missed that one. Oh. Well, I'm not doing it again, right? You could go back in and fix that, and you'd get the right answer. Careless, I'm on good here. I got an 18 puzzle, which kind of attracted my attention because it looked weird. A car travels along a straight road heading east for 1 hour. Okay, that's my car, heading east for 1 hour. Then traveling for 30 minutes on another road that leads northeast. Right, well, northeast is going that way. And I do that for 30 minutes. So I'm going to have to write down some stuff here. I go that direction for 1 hour and then turn, do northeast, which is this guy. And I do this one for 30 minutes, okay? And my speed is constant, and it's 64 miles per hour. And they ask us to find how far away from the starting point I am. Well, let's see if we can put some numbers in here. If you do 1 hour at 64 miles an hour, would you agree that is 64 miles? At 30 minutes going at 64 miles an hour, won't you only travel 32 miles? Are you happy about the two lengths of those sides? Now, there's something missing here to find x, and there's something missing is that angle. And they did give us a clue. This is east, and this is northeast, right? So if I do a little north, south, west, and east, isn't northeast that direction? Agreed?
Yeah, so would that be a 135-degree angle?
I like your thinking. Would you agree that this guy here is 45 degrees? And then wouldn't you agree that if you do this guy, which is the one you want, right? That's I'm assuming, isn't that how you came up with your 135 that you mentioned?
Yeah.
Right, or a similar way to that. Now this time I'm going to make sure I hit the right buttons and with the right numbers. Would you agree it's a cosine rule? Two sides of the angle in between. And this guy's going to be called x, you can call it anything you like. I'm going to have to put some names on these guys. So that's as good a naming as any. So if this is angle A, this guy here is little a. This is angle B, that's what this guy's going to be called. And this is going to be what C is called, right? Because I need something to be called A, B, and C, don't we? Or else the formula gets a bit messy. In this case, aren't we looking for little b? So b squared. And the formula then is going to be a squared plus b squared, take away 2ab cosine of b. And a happens to be 32. B happens to be 64. 2 times 32 times 64 times the cosine of 135 degrees. And B is going to be x squared. It's okay if I turn it into x's now because B is x. Now on the calculator, being extra careful this time, 32 squared, add 64 squared, take away 2 times 32 times 64 times a cosine of 135. Does that look good? Right, so when I hit enter here, I'm going to get the x squared is 8,016.309 and some lots of stuff. But I just want to know the square root of that because that's what x is. So I will just go square root and then use the answer button, which basically types everything in for me. And I come up with 89.5 to 1 decimal place. And that looks too good to be wrong. Does that look good? Right. Context can sometimes tell you if you screw up. If this is 64 and this is 32, would you agree this is going to be a little bit different, right? 64 and 32 add up to 96. Won't this be a shortcut? So shouldn't the answer be at least less than 96? Does that seem reasonable? Right? That guy and that guy, this is going to be quicker, right? It's a shortcut. So doesn't that match my intuition? I'm expecting a number to be less than 96. If I thought that was 189 or 895, wouldn't you go back and look at context and say, how could that be 800 miles when this is only 60 and 30, right? I mean, that don't make sense. You agree? See that previous question where I thought the answer was a bit small? I think my brain was telling me that looks a bit small and I would probably have to check my numbers and, check the answers. If I look at them over here, they tell me them. Are we comfortable with that question? So I'm going to create my own little puzzle one. And here we go. The math that we are using has existed for a very long time, right? Trig ratios have been around for a very long time. So here is a castle wall, right? And they are trying to estimate its height, because they're going to attack it. The problem with attacking a castle wall is you can't really go up to the bottom of the wall with a big tape measure and measure it, because aren't you probably going to get your head shot off long before you did that? So you want to do it at a safe distance. Yet, how would you do that? Well, you measure to the top of the wall, and the angle happens to be 30 degrees. Okay. So imagine you get one of those little, it's just basically like an eyepiece with a little string on it. And so when you move it up, it tells you what angle you've got. So you're comfortable that that is measurable. And couldn't you do that far enough away from the castle wall that nobody can kill you, right? And then you move, let's say you move 50 feet nearer, still safe, right? Still away from the wall. And you measure this angle. And this time the angle ends up being, make it nice round numbers, 45 degrees. And this guy here is a right angle, obviously, because the ground meets the wall, it's vertical. I have given you enough information to eventually find the height of the castle wall. And would you agree that is a safe way of doing it and not getting killed? People who do surveying, even today, you know those guys with those little theodolite things and lasers on them? Do you know all they're doing is a very simple, a more electronic version of this? And what that does is it allows them to find, how tall this building is without having to measure how tall that building is, right? Or anything at all, right, to do with distances or angles. Now, it looks like this picture has got some stuff missing. But before I get there, let's just call this guy A, call this guy B, call this C, and I'll call that guy D, right? So I've got all the corners labeled. I know the size of that angle. So should you. How big is it?
135.
Correct. How did you figure it out?
Well, if you do 180 minus 45.
Great. Straight lines are 180. So I'll put that guy in. I also know, I haven't drawn it very well. Don't I know the angle at C up there? Great. How big is angle C?
15 degrees.
So when you have a puzzle like this, do you know the first thing I tend to do is write down everything I can get for free? Would you agree those two angles I can get without doing too much work? Once I figure out I've got every angle that I could probably want, then I would continue. But I think I can do one more angle. In that picture, there's one more angle that I can get the size of. What's the size of this fella?
45.
Great. Okay, now we are after the height of the castle. I'm not going to get that directly. Which one of these sides on this kind of squashed triangle, which one of those sides am I going to find to help me eventually get that guy?
It would be little b, right?
I'm not sure if little b is the one.
Well,
Well,
Okay.
oh, you're saying little b is this guy. So I guess I'll put the names on. This guy is little b, okay? This side here is called little a, and this side over here is little c. So a, little b, or little c. Which one of those am I going to get?
Sorry, you're gonna want little a.
Agreed. So do you see why he chose little a and not any of the other two? Well, obviously I know what little c is, but why he didn't choose little b, for instance? Don't see. If you know a, don't you now have a right angle triangle where you know one of the sides? Can't you use SOHCAHTOA to get the other? Does that make sense? That's why he chose that. So just to make...
Technically, I think you can do little b as well, because then you just have a right triangle and you can find x that way.
you do have a right triangle and you could find it that way. You're quite right. And there's nothing wrong with you picking, you know, whatever method comes into your head. And the reason I'm choosing this method, partly anyway, is so that we can use, well, you tell me, to find little a, sine rule or cosine rule. To find little a, sine rule or cosine rule.
Was it sine rule?
Yes. So if you're not sure which one, then go back to that statement at the beginning. If you are looking at a triangle where you know all three sides, it's a cosine rule. If you're looking at a triangle where you know two sides and the angle in between, it's a cosine rule. If it ain't those two, it's a sine rule. Would you agree that is one of those, it ain't those two? And that's how you can decide. Now, in this case, you know all three sides, which is good news. I want to find A and I know little c. So you agree it's these two that we use, the A and the C combination. And so sine A over little a is sine C over little c. Oh, I guess I should be putting the names on them, aren't I? That's A, that's B, that's C. So the sine of 30 degrees is equal to, over little a, is equal to the sine of 15 degrees over 50. And continuing with this, you would do cross multiply. Then you could divide both sides. And this one is just button pressing, we're done. 50 times the sine of 30 divided by the sine of 15 degrees. And A is 96.6 to 1 decimal place. Now that I know A, which is 96.6, and I know this is 45 degrees, and I know, well, don't know, but I want to find that guy. Can you see that I can now do SOHCAHTOA, right, on this triangle? Now, if you name the sides, this side is called the opposite, and this one is called the hypotenuse. Which one of the SOHCAHTOA formulas use opposite and hypotenuse?
Sine.
So we are going to be doing the sine of 45 degrees is the opposite over the hypotenuse. And if you do a little cross multiplication, then 96.6 times the sine of 45 degrees is the guy you're looking for. And since I've got that number in front of me, I'll just use that. It's more accurate anyway. And the sine of 45. And we get that it's about 68.3 feet high. So if you want to attack this castle, don't you want to make sure that your ladders are bigger than 68 feet long, right? And because aren't your ladders going to be a little bit beveled, won't you want maybe 80-foot ladders or 90-foot ladders, right? So, you know, the medieval attack on the castle, you ever seen the movies? They carry ladders, you know, rush up to the side, stick it on the wall and they all climb up. And you ever wondered, how do they know how big the ladders need to be? Because couldn't you come up with a 50-foot ladder and you do all that fighting? 50-foot ladder. Uh-oh, we're in trouble, guys. Right? People are killing you all the way in. Won't you have to turn around and get killed all the way back out to find bigger ladders? You don't want to have to keep doing that all day until you figure out how big the ladder needs to be. Can you imagine that would be quite a useful way of avoiding that? It's also a useful way to find the height of something if something's in the way. Could you imagine the same kind of story? We won't do the numbers, I'll just do the story part. Imagine that there's a big tree somewhere, and it's at the banks of a river, and you don't want to have to cross the river just to find out the height of it. Then, couldn't you stand somewhere here and get an angle, I don't know, 40 degrees, move in 10 feet, do another guy, maybe make the angle here 70 degrees. Isn't that enough information to eventually get the height of the tree? And you're nowhere near the tree or getting drowned. And from just one point in space, couldn't you look at all sorts of objects and find the heights of them without actually going to them? Just staying in the middle, walking 100 feet, measuring the angle, right? Go back to the middle, move towards the other object, maybe 50 feet, 100 feet, whatever you feel like. Any questions about that one? We feel good about them? Draw pictures, fill in every one. Got another puzzle one, and this one is a picture that you're told the angles. And basically, this is north, this is west, this is east, and this is south. You know, in the olden days, people probably, if they didn't have compasses, wouldn't they walk northeast? But, you know, aircraft don't fly northeast, don't they fly 42 degrees? So they're quite accurate about the directions. And directions are measured when you do aircraft and ships and so on, that north is considered 0 because you use a compass, right? Or you use sophisticated satellites, but north is still 0 degrees. You all know that? So we are going to measure angles from north. And so in this direction, we're told that this angle here is 50 degrees. And somebody's traveling in that direction. So it's a ship. A ship is traveling 50 degrees in that direction, and it's doing it for 34 miles an hour, but it only travels for 1 hour, so that's 34 miles. And then there's a totally different ship, and it's down here. And that angle in here is, according to them, 70 degrees. And this second ship is going to be traveling at 50 miles an hour. So that makes, in 1 hour, that one. So what we are going to find is the distance that the two ships are apart. So you can imagine I'm going this way, you're going that way. After 1 hour of traveling at 34 mile an hour or at 50 mile an hour, can you see how far apart are you? Now, this question involves us creating angles from that picture. And no particular reason, I'm going to call this guy A, this guy B, and this guy C, right? Got to call them something. So A, B, and C sounds like a good deal. Do you agree? Now, let's focus on this guy, because it's the only guy I'm actually going to find. Can anybody tell me how much that piece is?
40.
How did you figure out, Ali? Because you're right.
90 degrees minus 50.
Same argument, would you agree that's 20? So doesn't that make this 60? Do you see how we had to fight a little bit for that angle? It wasn't like handed to you in a plate. Now, don't we know this guy is 34 and don't we know this guy is 50? And we're trying to find that guy. Sine rule or cosine rule? What will find the missing x in this story?
Cosine.
Agreed? Because two sides in the angle in between. And I'm not finishing that question. You can do that on your own. So what are we left with? Well, we only have a little bit to do here. There are a couple of questions to do about finding areas, right? And then there's a kind of puzzle one that I'll talk about later. Right, let's go here. Here is a formula for calculating the area of any triangle. Now, the only formula you probably know is half base times height, but isn't that only good if it's right angled? Here is a formula for the area of any triangle, a half AB sine C. Now, to use this formula, don't you need to know A, B, and angle C, right? So imagine I gave you a triangle and I tell you this is A, this is B, and this is C, and that's little A and it's 10, and that's little B and it's 15, and this is angle C and it's 20 degrees. That is all you need to find the area of that triangle. Its area then is a half times A times B times the sine 20 degrees. And you go here and you go a half, which is 0.5, times 10 times 15 times the sine of 20. And bingo. You can round that off to say 1 decimal place. And I don't know what the units are. They don't even tell me, so square units. So the area of this triangle is that. So suppose I give you a triangle, I'll call it ABC again, and I tell you this is 15 and this is 8, and I tell you this guy here is 95 degrees. If we name the sides, do you notice that you have to change the formula to accommodate the sides? It wouldn't be any good to do a half AB sine C because I don't know what B is. Agreed? Now, could I find the size of B using the cosine rule and then use this formula? Sure, but wouldn't that be a lot of work? Can someone adapt this formula to this circumstance?
1/2 AC sine B.
Nailed it. Agreed? Have you noticed that these triangles are the same triangles that a cosine rule uses? Agreed? Right? Two sides and the angle in between. Now, what happens if I give you a question where you're still being asked to find the area of the triangle? And I tell you this is 10, that this is 12, and this is 8. But I want to know the area of the triangle. And the formula for the area of the triangle that I'm going to use is a half AB sine C. Because I like that formula. Right? I try and use that one if I can. What do I not know? And I need to know to use this formula.
The angle?
Correct? Which angle? Which one?
Any angle?
Well, okay, but in this case, since I've written that,
Oh, yeah,
C.
see.
But if you want to use B and A, go ahead. It works perfectly fine. So don't I need to find that angle? So this is a two-tier question. Isn't this a question where you have to find something first before you can answer the question you were asked? What rule, sine rule or cosine rule, will I use to find C?
B cosine.
Right. So not going to do it because we have a time issue, but can we pretend it ends up being 15 degrees, just for argument's sake, right? It'd be a miracle if it was, but if it was, you would then go a half times A times B times the sine of 15 degrees, right? Or whatever that ends up being. So if you are given a triangle and it looks like there's things missing, like in this case, an angle's missing, doesn't that give you a clue? Okay, I've got to find an angle. And like somebody says, well, I like A. Well, go ahead. But if you find angle A, aren't you going to have to change your formula to be a half BC sine A, right? If you're going to do that, you have to adapt the formula. That's fine. Are we okay with that little special question, find the area using the formula that I've just given you? We good with that? Right. Last guy. Perfect timing, because this is going to be the last thing we do, is, and I'm going to show you because it's very visual. And it's on the homework and it's question 16. Maybe make it a little bit bigger. Now, here is a triangle. This guy here is 100. And you're being asked to find the area of the shaded region. Well, the first thing you should be looking at here is saying that isn't possible. So I want you to imagine that I draw a line from this corner here to here. Do you see this shape is now two triangles? And I know W is 7 and I know X is 8. So can't I just do the half AB sine C and get the top triangle? I also know that Z is 10 and Y is 9. And remember my invisible line. You might say, well, that is not going to work for me because I do not know this angle. Agreed? So I'm now going to draw a little picture of that now that you kind of see what I'm talking about and show you how you could go about this. So this is 100, W is 7, X is 8, Z is 10, and Y is 9. So I don't have the time to do the details, but I will have time to show you how to approach this question. Right. Remember, we decided to split it, right? Now that top triangle, can I just say its area is going to be a half 7 times 8 times the sine of 100 degrees. Although I haven't put the letters in, would you agree that's the calculation? Now we need this angle, don't we? Because once I know this angle, won't I then be able to do the area of that one? And won't it be a half times 10 times 9 times the sine of whatever we find out that angle is? So here is the quest. How do you find that angle? Because you've got to find other things first to find that angle. And the clue is, work on this triangle at the top first. Is there anything on that top triangle that might be helpful to get this angle?
You can use the cosine rule.
Agreed.
Right? Of 8 squared plus 7 squared minus 2/8 times 7 times the cosine of 100. And that'll give you that length.
That length. Now, I don't know the answer because I don't have time to do it. Can we just pretend it's 11, just for argument's sake, right? Now that you know that it's 11, how are we going to get this guy? So now you're focusing on the bottom triangle.
Cosine law again.
Right, and let's just pretend that the answer ends up being 50 degrees. I know it's not, but pretend it is. aren't we able now to stick in 15 degrees here? Okay. Now, this answer plus this answer is the answer to the whole shape. That makes sense. You add up two triangles. So I didn't, don't write down 11 and 15. Right? They're just made up. But are you comfortable the process that I used, how you would find the real answers? And that's the end of that section. And that's you covered everything for your homework, I hope. And last name and bye-bye. Did I mention everybody has got their reports? They're in your email. So if you haven't seen your report, the email I used is the one you used for WebAssign. If no report has arrived, you'll need to shoot me an email and put in that email the email that you want me to use, and I will send it out to you. Okay? Check it over for things like I was here all last week and you said I was missing a day, and I can check it, right? If anything doesn't add up. Yeah. And Caitlin, that's a Jack Russell you've got, and it looks very like a Jack Russell.
Half Jack Russell, half Chihuahua.
Ah, that is a cutie.
She's been wanting my attention this entire class.
Well, my little dog, Chloe, has buggered off somewhere, which means she's probably biting my wife's toes because she's started chewing on toes now. I have no idea why she thinks they're edible, but I think she likes the reaction. Oh, and oh, that was fun. I'll do that again. Dogs are strange creatures. Okay, bye-bye, guys. I'll hang about. I know at least one person has a homework question. If you've got one, hang about for it as well.
I
Otherwise,
just have a question since I missed last meeting.
okay.
Since you record these lectures, do you post them?
Yeah, if you go into Canvas, you'll find them there.
Okay, thank you.
No problem.
I have a question from the 6.4 homework. There's one question that wanted me to rewrite something in terms of x. It was the sine of inverse tan of x. Okay, so let's see. You have the sine of the inverse tan of x. Is that what the question was? And they wanted you to rewrite this in terms of something else? Of x, yes.
In terms of x. Did they have a number here, like a y or something that I can work with?
No.
Now, can you tell me what the question number is then? It looks a bit strange. Do you know what number it was?
I think it was 21 for me.
Okay, so way at the end. And you are right. This is the guy. So, interesting. Well, let me look at that guy. All right. If you say inverse tan of x, what does that tell me? Well, if I look at a tangent function, if the answer, if we make this angle theta, let me rewind a bit. I'll write the original question and then I'll slow down a little bit. I am going to assume that that is equal to theta because inverse tans tell you angles. And so this is saying that the angle that gives you a tangent equal to x is theta. And the reason I'm doing that is I can build a right angle triangle and I can make this angle theta. Now, what do you know about the tangent? Isn't it the opposite over the adjacent?
Yes.
Great. So if I call this O and A, and since it's x, can't I call it x over 1? Are you with me so far?
Yeah, let me,
right.
Would you explain that triangle one more time? I'm sorry.
Right. So if I say to you, the inverse tan of x equals theta, right? Then if you rearrange that, isn't x equal to the tan of theta?
Okay, so then x is equal to the tan of theta. Oh yeah, okay.
And then I'm going to call x over 1. And that means I can say opposite over adjacent. And from this, I create that triangle. The tangent of theta is opposite over adjacent. You with me
Okay.
so far? Now,
Yeah.
according to Pythagoras then, won't this side be x squared plus 1? Because you square those two, add and square it.
Okay.
Right. So this question is actually the sine of theta. And what is theta but opposite over hypotenuse? And so in terms of x, opposite is that guy, and hypotenuse is that guy.
All right. X over.
The
Okay.
opposite, x over the hypotenuse, x squared plus 1. So the trick here was just to realize that that guy there is an angle, and let's call it theta. And then that will allow me to build a triangle with the angle theta in it. And from there, I
Okay.
could do it. I mean, for instance, since this one is here, if they'd said to you, find the cosine of the inverse tangent, I would say, oh, you want the cosine of theta. Well, that will be adjacent over hypotenuse.
Yes. Okay.
And I could do any secant, cosecant I wanted as well if I wanted to, right? And that's how you tackle that question.
Okay. Do you think there would be a question like this on the test or no?
Don't know. It's a short
Okay.
answer. Don't know.
All right.
50% of what you do never appears on the test,
Yeah.
right? So it's a 50-50 chance. How about that?
Okay. Thank you.
Okay, any other questions? Is that
Not for
you
me.
needed? Caitlin, have you got something for me as well?
Yes.
Right.
I had a question that was find all angles theta between 0 degrees and 180, satisfying the given equation.
Okay, what's the equation you got?
Cosine theta equals 5/8.
That one?
Yes.
Now, to get theta, you can use the calculator to get one of your two answers. So if they're looking just for angles, I'm going to get one out of this one. So I'm going to go inverse cosine of 5 divided by 8. And the answer I get to 1 decimal place is 53.1. So far, so good?
Yes.
Now, there's two answers in the 4 quadrants. Right, this is called quadrant 1, this is called quadrant 2, this is called quadrant 3, and this is called quadrant 4. And all of them are positive in the first quadrant. Only the sine is positive in the second. Only the tangent is positive in the third. And only the cosine is positive in the fourth. Now, since this is a positive number, the angle that I just found is this one here.
Okay.
The second angle that they want us to find is the one that's in the fourth quadrant that makes an angle of 51.3 with the x-axis. So it would be this angle here.
Oh, gotcha.
But that's not the one they want. We always measure the angles this way. So this green angle is that. And now, if you take 360 and take away that bit, that's the second answer.
Oh, okay. Because I was taking away 180.
Now that 180 would get you a guy over here.
Oh, okay.
Right, and if you did add 180, it would get you a guy over here. If you take away 360, it gets you a guy over there. So if you want somebody in the second quadrant, it's 180 take away the angle, right? If you want someone in the third quadrant, it's 180 add the angle. But if you want somebody in the fourth quadrant, it's 360 take away that angle. So that might help you figure out, if you know which quadrant the other angle is in, second, third, or fourth, can't you use this? Where theta just means the one you got off your calculator. You see that again there.
Oh, gotcha.
Okay, do you have another question, or is that?
That was it. Thank you, though.
You are welcome. Have a great weekend, Caitlin.
You too.
I will see you on Monday.
See ya.